I'm Yo from University of St. Andrews, and this work is done with my collaborators Xiao-Shen, Steven, Paola, and my advisor Aaron Quigley. Today I will talk about a new tube-based gesture keyboard for single-handed text entry. But before that, let me show you a quick demo. One second. Yeah, I hope you can see because it's quite small. So now I'm tilting my phone to perform typing. So, for example, good morning. Welcome to my talk. And maybe thank you very much. Okay. So why do we need this new text entry technique? The motivation for this work is actually quite straightforward, but I think it's very important. As you can see, the mobile screen size has been growing over the years, and it makes the single-handed text entry and interaction very difficult on the large device such as a phablet. Why? Because there's a thumb reach problem where it's very difficult to reach all area of the screen using the thumb when you are gripping the phone. Also, there is a fat finger and occlusion issue. It makes it difficult to select precisely with the thumb. Of course, there is other solutions, such as you can buy the thumb extender, or you can always just use two hands. But what if the other hand is busy, such as holding up a cup of coffee or a bag? Also, what about using a smartwatch? Because using a smartwatch requires two hands, the one hand for wearing it and the second hand to touch the screen. And what about people with physical challenges, people with only one hand? Finally, what about the recent growth of head-mounted display, the virtual reality, augmented reality? How can we interact with this new device with using only one hand? In general, this single-handed interaction issue has been studied many times. Therefore, in this work, we will only focus on the text entry aspect of this single-handed interaction. In this work, we propose and evaluate a novel design point around a tube-based text entry technique which supports single-handed usage. Before I go into details, let me talk about some related works. And there are many related works in the single-handed text entry, so I will only focus on those techniques that either use tilt or wrist motion. So for example, you can see some of the techniques here use a tilt and tap, or twist and then tap, or twist and twist it again, or twist and wait the timer. And you might realize that most of these previous techniques have one limitation. They all only input one character after one action. Therefore, I wonder, can we overcome this one character limitation? So I look at the traditional way of inputting text on mobile keyboards, which is tapping one key by one key, for example, on the screen. So this is limited to one character after one action. There is also this technique called shape writing, or more commonly known as the gesture keyboard. So this is shape writing. You drag a path of the letters of the word, and then the word will magically appear. So shape writing is a wonderful technique. It is very fast and is very accurate, but it works best on the two hands. Because when we are using one hand and we are using a pretty large device, such as here, it still suffers from the problem that I mentioned before, the thumb reach problem and the fat finger problem. So, for example, you can see it's quite difficult to select precisely with the thumb. especially at this grip and this post, because you are basically using the side of your thumb to select, not the tip. And the accidental touch will occur because when you try to reach for the key on the very far left edge, the palm area might accidentally click the enter key. So can we perhaps extend this shape writing technique to try to avoid these problems? And yes, there is a prior work that extends shape writing to mid-air gesture, such as the one from Kai 15, and it shows very good result. However, tracking the finger precisely in mid-air is a very challenging task. And in this paper, they used the optical tracking system with attaching the infrared marker on the hands. So this is not very practical, not to mention that the system is very expensive. And a few years ago, on the April Fool's Day, SIGCHI released a new keyboard called Tilt, and this is what they call the whole body typing experience. So this is quite similar to our work, which I will show you later. But I just want to emphasize one thing, and this is not real. This was an April Fool joke, and if you notice carefully, the ball on the screen doesn't do any gesture or shape writing. The ball merely hit one word from the suggestion bar and pick one of them. And now let me show you my system, which is real, by the way. So it's called shape writing in motion, swim. So our technique is based on shape writing. However, instead of drawing the gesture with the finger or a stylus, the user articulates the gesture by tilting the device. This can be especially useful when the user's other hand is encumbered or unavailable. Compared to previous work, it supports inputting one word per gesture instead of just one character. So let me explain how does it work. You tap on a button on the screen and then you tilt the device to control a pointer ball to trace the path of the letters, just like the gesture keyboard and the shape writing. And then you tap again to stop and the words will appear. Let's see some example here. For example, I'm typing the quick brown fox jump. Okay, let's see another sentence. Do you like to shop on Sunday? So this is running in real time, so there is no speed up or whatever. Oh, after each sentence, you can also swipe right to enter, or if you did some mistake, just swipe left to erase it. It also works on other form factors, such as a smartwatch on the left or the huge table on the right. Previously, it was nearly impossible to type with one hand on this kind of device, but now, by using Swim, you can. What about other emerging form factors, such as a VR controller or the smart ring? Since this device usually have a built-in gyroscope or an accelerometer, so we can easily adapt our swim technique to it. Okay, then what about Google Glass, the VR AR headset like HoloLens? Yes, because they also have the built-in gyroscope accelerometer, which means we can also adapt swim technique to the head gesture. So can you imagine that using your head to perform the gesture keyboard? Perhaps like tilting your head like this. Oh, sorry, I just hurt my neck. Yes, it looks like this. I will leave the question for you to think about it, but let's talk about some design and implementation. So in our design, we base our design choice on previous work, such as the two at the bottom of the slide. For controlling the ball, we use the position control. This is very important. And I just want to clear one misconception that tilting the device is difficult. So if you have played this kind of maze game on your phone before, it's difficult. Why? Because the game was designed to be challenging so that it's fun. And the ball, they use the velocity control so that the ball is affected by the gravity and the momentum. But in position control, the ball is directly mapped to the tilt angle of the device, and there is no delay. So it will be much more easier. And then we smooth the pointer ball position using the 1 euro filter, and we limit the tilt angle to plus minus 30 degrees because for a better visibility, and also because the wrist is more sensitive within this range of motion. Finally, we inject the touch events on top on the phone on top of any application, which means that our technique can work on any gesture keyboard on the market, such as a Google keyboard, the Swipe, the Swift key. And the most important thing for me is I don't need to reinvent the wheel. Now let's talk about some results. We conducted a short study with 12 participants with just 3 blocks, using the transcription task, which is very common in the text entry study. We can see that on the left, the swim is about 15 words per minute, while the one-time typing and the one-time shape writing is much faster, 25, nearly 30. So it's slower, which is kind of expected because these are the novice users using an unfamiliar technique. So we also conducted a second study using the composition task. Compared to the transcription task, in composition task, the user needs to reply to a sentence instead of just typing out the sentence that is provided. The user needs to reply to a sentence using their imagination to come up with their own words. So this can be a more realistic representation of the real-world typing speed. And again, swim is slower than the other 2 techniques, the one-time typing and one-time shape writing, and this time the gap is even larger. But one interesting thing here is we can see that on the right side, on the right figure, swim shows the increasing performance, but the other 2 is kind of saturated. Nonetheless, this is a very short study with only 30 phrases. So we asked the one volunteer to continue with a pilot longitudinal study with 5 more sessions. In total, he typed 180 phrases for each technique. From the figure, you can clearly see that the swim shows the increasing trend, but for the other 2 is rather saturated. And in fact, at the end of the 6th session, which is 18 blocks, the swim approaching the speed of one-time typing. And this is about 90 minutes of usage. And if we go back to the first study and look at the per-user result on the 3 techniques, again, we can see that swim shows clearly the increasing performance, the upward trend, even though with only 30 phrases. But for the other 2 techniques, it's kind of a mixed result. And I just want to highlight that on the left for the typing, why the line, the speed is actually decreasing when typing more sentences? It is because one of the participants, her hand was very small, and she felt fatigued when typing, the time reach problem. So even just after a few sentences, she felt fatigued, and it was very difficult for her to type. So there are much more details in the paper, but just let me highlight some key insight here. We use the 5.7 inches font, the Galaxy Note 3, which is a common favorite size, and it is not too big, so we can still run the study. So we observed there are some grabs and grip issue. There are some accidental touch from the palm area. And we observed that none of the users were able to grab the phone firmly when typing with one thumb, except when they are using the swim technique. The user also need to shift their grip very often. And luckily, the phone didn't drop in the experiment because it was my phone. But we can easily imagine that, I can imagine that it happens during the actual use. So I just want to say that it is not possible to directly compare the performance figures across different studies as there are many different variables. However, as an indication, the swim-related performance compared to the previous work, we note that swim mean entry rates surpass those previous published methods. And we believe that the expert performance of Swim can increase further because Swim is built on the principle of gesture keyboard, which gradually transition people from slow visually guided closed loop interaction to fast open loop direct recall from motor memory. And yes, from our pilot long study, that we can see that the improvement on Swim is much more higher than other two techniques, 100% compared to 20-30%. Finally, most participants mentioned that they primarily type with two hands because they acknowledge this difficulty of one hand typing on a large device. And this comment is very important for us because it validates our motivation for the work. And finally, in the future work, we aim to improve the system and investigate which factors affect the tube-based shape writing. We also want to support new form factors such as smartwatch, VR, ring, remote controller, stuff like that. And we want to conduct a more in-depth and longitudinal study. Especially, we want to explore how many selection, deletion, or replacement performed by the user. Finally, I want to emphasize this. Swim is not meant to replace single-handed or two-handed typing in all situations, but rather to facilitate text entry when using only one hand, when only one hand is available, or when using a large device or small device. And yes, that's all for my presentation. I'm open for questions. Thank you.
Caitlin Syme, Georgia Tech. I like it. It's fun. And I really appreciate that on the watch you can do it without touching it. But I have to call into question three things. And I would love to hear your response on it. The wrist range of motion, to do this motion, it's very uncomfortable. So even if you're just doing 30 degrees, it's a very unnatural motion. Even in your demo, you had it operating in the hand. So
yes.
I question the real utility in that. Secondly, I wonder about the adaptability of this technique because it's a complex motor task. You see how there's a lot of learning that has to be done. And a lot of people might not want to do that, but it is fun. It looks fun. And third, I think your presentation of the first 30 trials and the improvement factors is misleading. I would love to hear your response on this, and I'll tell you why I think it's misleading. These participants, I presume, were familiar with texting using the tapping method, and as you saw in the statistics, whether or not they used gesture typing, it had walk-up usability, where both those techniques were at least 10 words per minute faster than your technique in the beginning. Your technique was so difficult to learn in the beginning. Of course there was improvement because these were total novices and they had to learn the technique. The other two techniques were either familiar or had walk-up usability. So the improvement was because your technique started out at least 10 words per minute slower and more difficult. So I would love to hear your response on that.
Okay, I hope I still remember all three questions. The first one is about the smartwatch, right? Yeah, so if you consider there are some other watch that is not worn on the hand, like the lapel or the necklace watch, then you can use it. And I agree that when wearing the watch, this motion is kind of difficult to use. But you can also limit the range of motion that is more sensitive. Instead of using a big motion, you can limit to a smaller motion. So yeah, it's one of our future work, and we want to study about it. Then what's the second question again?
It's all right. The last question is the most important. Do you have any comments on the improvement factor you presented and how it might be more representative than my impression?
I want to emphasize again the last sentence I mentioned, the conclusion. So it's not meant to replace the single-handed entry in all situations, but during certain circumstances like encumbered, one-handed, so it can provide a useful solution for quick text entry. And yes, the performance is much lower than the typing and the shape writing. Yes, but this is still an ongoing work, and I think with further improvement, it might be better. So
I think it showed a lot of promise, and I think two things you could say instead, real quick, is that instead you could say that it was learnable, and with the curve, you showed, so first it was learnable, and second, I saw that at the end it was equivalent speeds to normal texting. So I think those would be some really great points that you could put in instead of the improvement factor.
Maybe we can take the discussion offline.
Thank you.
Thank you.